No. Hello, everyone. So in this video, I'm going to test out the new addition to random panels, which is the parameter called Inset Clear. So basically what this does is instead of removing the panel islands based on the percentage right here in the panel amount parameter percentage bar. So when I create a detail and use the panel amount parameter to reduce the amount of existing islands in the random result. So it gets removed from being inserted or extruded. And when you toggle on remove panels, those faces are then deleted. We have a new parameter now, which is going to be called Inset Clear. So instead of um, getting rid of those faces, they are instead turned into their own island. So as one disappears or gets removed from the randomization, it gets inserted or extruded, but um, the it goes to join. So it joins the other islands as one single as other it joins the other islands as new islands that are so I can so okay so this disappears and island 2 disappears, so number 1 island becomes joined with number 2 islands, so they become basically a single island. And this is a good way of reducing the noise in the randomized result. As you can see here, um, if we go back to 100% panel amount, and you can see there's a lot of noise here, especially those single face islands, and you can reduce those by using the panel size, by increasing the minimum amount, increasing the maximum amount. Okay, so but because of the way that the islands are created, the there can still be some of these small islands that remains. So especially with square solver, so with radial there's less of them, and with walk, of course, there's gonna be a lot. With maze, there's gonna be a lot. So square, walk, and maze are basically like a tier in levels of noise. So I think the noises will be maze and walk. So they're kind of equal to each other, and then the second one is square. And the less noise is radial. So let's try it with square. And let's get back to 5 panel size minimum and 30 maximum. So when you enable Inset Clear, instead of getting rid of those islands, it's they merge into each other and become new islands. So we have the invert panel mount here. So it does its best to get rid of the small islands first, as you can see. And when you reverse this, you invert the toggle, you turn on the invert toggle. It gets rid of the big islands first and keeps the smaller islands last. And when 0, there's no, basically just a single island. So if you get this, for example, and you want to reduce the overall noise of this, you can just use the Inset Clear to do that without actually changing the panel max size and minimum size. So just another way of making sure that the greeble is less of a greeble look when you actually go in and modify the model some more. So this is at 30% panel amount with Inset Clear enabled using the square solver. and this is 100%. Okay, so I'm going to load a file that has the masking. Okay, so this mask here is the split, and this is the mask. Yeah, the mask and the split. So the split becomes its own island. The mask is where the randomization is excluded, except if it is inverted. Okay, so we're going to use the preset that is going to invert it. Use face tags inverted. So the randomization actually shows up on the mask itself. And let's increase the resolution. So let's try it with this kind of level of noise, and turn on Inset Clear, and begin reducing the panel mount. Okay, so we get this. So less there's less noise and more relaxed detail. Now you can play around with the panel seed, and if you see that there's not a lot of detail, you can just increase the panel amount again. So let's say 25%, and I think this 25% is looking better with this subdivision. Remember that the amount of details that are going to be produced by the randomization is um, relative to subdivision and the panel size, min and maximum. Okay, and also the kind of solver that you're using. So 25%, 30%. So if I reduce this to 4, there's going to be less detail, and we get this. I think I like this. So the point of this is actually to come up with a greeble that you can repurpose into something that looks functional. So you basically go in after you have randomized and make sure that you get rid of the greeble look. And I think that will the updates that are coming out are going to make that easier. So I'm just going to randomize the depth, and then go in and let's try and make sense of the greeble here. And I'm going to use the random offset. So for the topology or the resolution, we can actually make use of the resolution to help us model additional stuff to the mesh. And we can just get rid of the whole resolution afterwards using limited dissolve or using quad slice to basically limit dissolve and then quad slice to bring back the quad structure, but less this time, less resolution this time. Okay, so random offset and then extrude. I think I'm going to use this to 0.05. Not 0.005, I mean, in the update. Okay, so with random offset, this is the result. The top faces are still going to be selected, so you can go ahead and just scale afterwards, like that. And so you can also do this with inset. You can see inset and that, but you have no options to sharpen the edge. Inset, you can do that. Inset individual, you can do it with inset. But you can, we can also clip center. And there's also the margin. And you can also randomize the scale, the margin, and the offset. So it is more advanced than the actual inset. Let me just show you here. It's actually made to randomize the offset of the final islands, just in case you don't want to randomize the depth. you can do so manually afterwards using random offset. So let's use pre-select to select this faces, and then let's use random offset. Get back here, and the preset value is too strong at the start. So let's just reduce that, and I'm getting okay. That's the scale again, and then reduce the offset like that, and then we can randomize the offset like that. There's also an option to remove the border edge from the selection, but sometimes it can cause damage based on the topology, so just watch out for that. So basically, that's to get rid of the sharp edge from the original selection, which is inserted here. Well, there we go. So you can manually offset the panel islands afterwards. And you can also do that again and get this kind of beveled look like that. Then you can of course go in and just use it as basic inset or extrude. 0.005. You can go negative offset like that, and then create a margin. You have to modify the other parameters as well, because if you increase the margin, you of course affect the scale. So you can do stuff like this, and then this. Okay, let's do some sort of handle right here. Offset, margin, and then scale. Select this opposing faces using pre-select, inset, and bridge. Okay. So do your best to actually um, get rid of the greeble look. So this is a crate, so I have to actually create a sensible opening for the part that actually opens in the crate. Okay. So this is kind of the design is it's a kind of storytelling. Yeah, let's use panel cut. Panel cut will also receive an update because of the changes in random flow. Now all you have to do is just repeat these actions. You can also use individual inset like that. So don't worry about this ingun right here. We can go to smooth. Okay, so now it looks better because the greeble look is gone, as you can see here. And I'm going to use a material on this. So let's just go ahead and random color, island, and No saturation. Island again. So I'm going to save this. Save one and go here. So this is on one of my YouTube shorts, and this is the TIE fighter that I modeled using the same principle. So basically now you have more control over the greeble, and there's going to you have more tools to actually lessen the greeble look, as I mentioned, and you can use the randomization more tactically this time. It doesn't look like dribbled detail. It looks manually modeled. Just because you added something on the design manually and not just leave it at the hands of just like pure randomization. Okay, you go in and edit. So just that little action can give you a lot of believability in your design. Let's actually go here, and I'm just going to grab this head hammerhead and go back to our model. Control V and then delete this. The purpose of that is just to copy and paste the material that's included in those objects. Sun material, metalhead. Okay, what's wrong with this? The bevel. And we're going to change the HRI. We actually got a good one right there, but I pushed the button again. Okay, this one. And we're just going to edit this 0.005, okay, 0.003, 0.001, okay, 0.001. And then those edge works looking really fine, and it's because of this cavity mask. It's not because of the edge mask, it's actually because of the cavity mask. And the peaks, there we go. So as you can see here, it doesn't look gribbled at all. Okay. Now, when you manually model your detail onto those gribbles, you need to tell a story. You need to make it make sense to the overall design. So when you randomize, you need to look out for the pattern that will let you easily do that, and not just randomize stuff. So for example, here this is used as strap for straps that can hoist up this model or object. And the opening of the crate itself will be this, and you can model some handles here. And this is more like this part here is more like a module that can be attached to this main body, and it has many functions. You can create screens, computer LCD screens here with a HUD. So this can, for example, cool down this unit, and of course bring about this other stuff here like this strap what do you call this, strap holder, and other stuff like monitoring the inside of the crate. So yeah, you can still tell a story by the design itself, and that's how you get rid of the gribbled look. And the journey actually started here. So here, I tried my best to actually come up with the randomization that actually looks um, right related to the design, but um, couldn't get anything, so I just settled with this really simple layout. The better choice would have been to mark sharp the edges and create a pattern that could be used to create panel islands using panel cutter. So there's no randomization. And the other randomization part here is this one. And this one is the, I believe I used the beveled type. And this one here as well. So as you can see, the base, there's no story here. They're basically just, what do you call this? Aesthetics. And this here is also randomized. So for something like this, that's is more design specific. Like I did model it from reference. This came from Fallout, the rocket hammer, and so there's for more focused design that you have like reference on. I think there's going to be less use of randomization in, but you can still use it tactically on some parts. Whereas compared to uh, this one, this is mostly purely randomization, and you use this basically to um, iterate ideas and design. If you're designing like a bigger scene and you don't have time to actually model those this kind of assets, you can use randomization to make this quickly. Create your own library with it. So this is advantages to actually just if you buy like what do you call this, kit bash assets in the internet. Um, if you use it more and more, your scenes are going to look like exactly the same in the long run. But if you build your own library of this, then your scenes are going to be unique each time. And you can do this in your free time. If you have free time, like 1 hour, 2 hours, you can build like one or four of this. And if you don't care about the getting rid of the greeble look, then you can of course create more of that. But if you want to go in and get rid of the greeble look and bring in your own design, then of course it's gonna take more time, and the amount of detail model that you can do within those few hours is less. So let's bring in some good old emission lights. Okay, and change this to emission. Where's the emission? Set it to 10 and something like this. Or blue. I haven't used blue. There we go. Then we just repeat this pattern here, or this light all over the place where it makes sense. And random offset, intrude, and just fix the other parameters. And then assign material, our emit. Okay, one more at the top, probably smaller. This place. Okay. Um, modify the settings. Margin, scale, and then assign material, our emit. Okay, so you can actually use this to create your own Git bash assets and sell them. Um, since I'm going to get rid of the topology anyways and codify it using code slice, you can just do this. Limit solve and draw cuts. We can just insert this. There we go. So limit the solve and then triangulate. Then you have a nice light asset to use in your scene. There you go. If you want to keep the quad structure, I'm going to save this. We can use, oops, we need to, that was wrong. Okay, actually that was wrong. We need to merge this first and then limit the solve, quad slice. Before pushing anything else, just go straight into distance to make it to make the operations faster. 0.01 XYZ, all faces. Uh, there we go. 0.025, 0.015. There you go. So some parts are a bit messy, but you can just fix those. Quad slice XYZ, 0.01, 0.005. Yeah, 0.015. And then you just fix this. These are mostly just, you can just go in and F, selected all faces. Why does it turn out like that? Tangent. Oh, station scale. Selected only. There you go. And just fix the, you know what? We just skip this and F and then triangular. There you go. Needs fixing, but that's how you bring back the quad structure. Or you can just, after the merge, you can just manually collapse these edges. So this edge, you cannot collapse this because it's needed here. But this edge here, you can collapse this. Control X, X. So this edge here, you can collapse. You can also collapse this. This edge, you cannot collapse this. It's needed here. Like this one, it's needed here. This one, needed here. And yeah. But you can do diamonds. Do you know diamonds? XC, collapse. Um, and redirect. So there's a lot of stuff you can do with the topology to fix it. That's why I need you to study and embrace ingons and tries, not just quads, because you need ingons and tries to make a better quad topology. So I guess it's already quads because of this one here. However, this kind of topology will be bad for subdivision. But that is a way that you can actually reduce the topology. If this part here is needed, then you can just create diamond and collapse the rest like that. And here, I think we can collapse this, merge it here last, and then create a quad structure here. So a triangle will defeat a triangle and make a quad. There you go. So that's it. The diamonds. Don't forget about the diamonds. Or if you don't want the quad structure, limit the solve and triangulate. This is what this is what I prefer. However, you kind of get rid of the quad structure, but there's really no need to. You just get rid of the triangulation when you want to model some further details and use the knife function, which is actually easier without all those quad structure in a way. You can use the knife or the draw function in creative flow. That and inset or extrude wherever you want. And from here we can the draw function automatically limits itself to the selection to the selected faces and only cuts those selected faces. Inset again, like that, and then just triangulate. If you want to export this to other app or sell this, you can actually sell this using this topology. That doesn't matter. It's only going to be a background asset anyway for them. So for beginners, this might look really ugly topology, but this is actually really practical because the only thing that's matter is this. As long as you don't see any distortion in the shading and geometry, doesn't matter about the topology. Okay, so yeah, it's going to be it in the next update, which is Inset Clear, and we also have the random offset. There's a lot more, and I'm going to list it all in the changelog when I update the add-on. Okay, so that is it for this video, and thank you for watching the stream. Have a nice day. How do you stop the stream?